So yeah, the Poisson probability distribution is one of the more beautiful equations in this course because there's a couple of interesting, it involves Euler's constant, and there's also a factorial involved. So for those reasons, it's just a beautiful equation from a mathematical point of view. I posted a video on our team's website from a prominent YouTuber called The Number File. This one over here. And he does an excellent job at introducing you to this number. You'll see it throughout your math and science career. It's a beautiful, irrational number that kind of pops up everywhere, right? And it's one of these irrational numbers that just goes on forever and ever and ever, just like pi. All right, so how does it apply to statistics? Well, it applies to statistics in the sense that it's going to allow us to predict the probability of rare events. So again, just as a quick recap, there's three parts to this chapter, right? The first one was the probability distribution tables. And here, you're going to be, the way you identify this is, well, the presence of a table, or there's multiple events, right? You use this when you have a situation where you know the probability of events that can occur multiple times. Or can occur multiple times. The next thing that we looked at in our last class, in class number 16, was something called the binomial distribution. And this is when you have a yes or no scenario, right? There's just kind of a true or false, pass, fail. Only two outcomes are possible. And today, we deal with the Poisson distribution or Poisson equation, which deals with what I'm going to call rare events. And you don't know the probability, right? It can occur multiple times, but it's rare. So rare events where you're not given the probability. So in 5-1, you know the probability of it occurring 3 times. But what if you don't know? You can use the Poisson distribution. So rare events that may occur more than once. And this is important in engineering because it predicts things like hurricanes and earthquakes and the probability of planes crashing or bridges, falling down, stuff like that. And so it's one of the more useful, I would say, equations in engineering statistics. Rare events that may occur more than once. And so that's a little bit of a cheat sheet for handling this. The other interesting thing, and they mention it right here, is that unlike other distributions that we've seen, time is going to be an issue. So I'm going to use the symbol. So just to differentiate, so again, the Poisson distribution can be defined as this: the probability of an event, and they use the mu on the formula sheet, but I use a different symbol to specify this. The fact that the average that we're going to be interested in is we're always going to want to know the average or the mean over a specific time period. That's another thing that makes it unique. And so I use the symbol lambda instead of mu, right? So in the formula booklet, they use this, but I find this not to be the best symbol because it can be confused. It's not the same as this one. Oops. I'm going to use the symbol this instead of mu, and again, that's just to differentiate it from, this is just the the mean number, whereas this is going to be over a specific time period. So I'm going to rewrite the equation as the probability of a certain number of events happening is going to be the average over that period to the power of x, in other words, how many times, and then e to the negative average over x factorial. So once you know, we're always going to know the average number, and then this is beautiful over here. The standard deviation with a Poisson distribution is the square root of that average. So that's a nice, beautiful equation there. Okay, so let's take a look at this one here. This is a good example. For a 55-year period, there were 336 hurricanes on the Atlantic coast of the United States. So they say assume the Poisson distribution. What is the average number of hurricanes per year? So this is usually the first step in all of these calculations. So when you're doing a Poisson solution, make sure that your mean is in the proper units, right? Calculate mean for the proper number of units, for the appropriate units. That's usually always step one, and that's challenging when you first try these things. Right? You could calculate it for 6 months. You could calculate what's the average per month. And often that's the case. They might say, what's the probability in the next week? So we'll do that as well here. But let's just do what they say first. So they say, okay, so if in 55 years there's 336, what is the average per year? So you would say, well, if you would have to divide, right? So this thing here would be 336 hurricanes, or 336 events, we can just call them, doesn't matter what they are, in 55 years, would give you how many events per year? Makes sense? So 6.109. Right? This is per year. And you could do the same thing if they asked you for weeks, or they asked you for months, or any other time frame. You just got to be careful that you do this calculation properly. All right. And then the next step, find the probability that in a random year there are exactly 8. So on average there's 6. So what's the probability that there's going to be 8? You would do this. You would say, well, the probability of 8, you just fill in the equation. So it's 6.019, which is the mu value, or the lambda value, to the power of 8. E to the negative 6.018, 8 factorial. So you can do that by hand, or just like everything else, you can use Excel as well. Let's do it by hand first. So we would go 6.109 to the power of 8, e to the power of negative 6.109, and divided by, whoops, let's not do that. Let's just go maybe answer divided by 8 factorial. So in other words, there's approximately an 11% chance, 0.1069. So you could figure out what the probability is that, you know, something happens in the next week or the next month. You just have to divide this by 12. Right? Let's say you had a problem that said, what is the probability of one or more hurricanes in the next month? And this is the power of the Poisson distribution, is you can change the time span, right? What is the probability of one or more hurricanes in the next month? So what you need to figure out first is what is the average per month? So you would have to take the value you have per year and divide it by 12, right? If the average is 6.109 per year, well, in 1 year, there are 12 months. So you would say, so 0.5091. And then you would say, okay, so what is the probability of one or more? So again, it's a good idea, just like we did last class, to kind of set up what exactly we have to calculate. One or more, so probability that x is greater or equal to 1 would be 1 minus the probability of 0. So you would say 1 minus, and then the probability of 0 would be, just fill in the Poisson equation. So for those of you that are wondering what's going on here, well, something to the power of 0 is always 1, and 0 factorial is 1. So remember that 0 factorial, according to the rule, is 1. So remember that. This will come back to haunt you if you forget that. That's important. And so really you can just rewrite this as the probability of no events. Again, that's a beautiful thing about the equation, and a beautiful thing about Euler's number is that the probability of a rare event not occurring is going to be just this, right? This is the probability of a rare event not occurring. Pretty cool. So 0.3990, 0.3990. Okay. So let me just show you how to do that in Excel quickly, so we can just check our numbers here. So if you do Excel, here's how you solve that. You would go, so if I want the probability of 8 events, I would say Poisson, as you can imagine, Poisson distribution. And like always, you have to enter a few values, right? You need to know, I'm looking for 8 would be the X value. I know the average is 6.109. And then you have to do that cumulative or not. Right? In this case, I don't want cumulative. I just want the probability of 8. So you get that same, that's the same number I got, right? Same number. So again, the way you would enter that into Excel is Poisson distribution, and you would enter 8, 6.109, and 0. And you can do the same thing here, right? So if I'm looking for this, you would say probability that X is greater or equal to 1 would be 1 minus Poisson. And you'd say, well, I'm looking for 0, 0.5, 0.91, and also in this case, whoops, also in this case, I want 0. Oh, that's a little bit different number, isn't it? What did I do wrong there? Oh, no, it's the same number. Just a significant digit thing. Right. So where would you want to use the true, where would you want to use that cumulative function? Well, that would be something like, what's the probability of 2 or more? Right? Like, let's say the question asked you, you know, in the next month, what is the probability of 2 or more hurricanes? Well, you would say I need the probability that X is probability of greater than 2, which would be 1 minus the probability of, what is probability of 2 or more? You say, well, probability of X is less than or equal to 1. So in that case, you would use cumulative, because this is the same thing as probability of 0 and probability of 1. So here you could just use the cumulative function. You could say equals Poisson distribution. Here you would say 1, 0.5, 0.991, and then put in the 1. You would go 1, 0.5091, and 1. And that would give you, again, cumulative function, same thing that we were doing yesterday or 2 days ago, or whenever it was, for the binomial distribution. Right, so they go through all that stuff that I just did. Okay. Yeah, we don't need to do this. I don't ask any questions really on the approximation. Yeah. We're not going to worry about this stuff here. I guess, again, the only thing that, we're not going to do this. It's not really necessary. So we'll call that the end of chapter 5 here. Again, one just last little thing. If you want to know the standard deviation, it would just be the square root of whatever your average is. So if you want to know what is the standard deviation or what is an unusual value of hurricanes, right? Because again, that's where the standard deviation comes into play. You would say, well, it's just going to be the square root of whatever the average number is, which is 6.109. So 2.47. So what would be an unusual number of hurricanes, right? An unusual number of hurricanes, therefore, Well, an unusual low number would be the average, right? Minus 2 standard deviations. So 6.109 minus, and an unusual high number would be plus. So more than 11, that would be unusual. Or less than less than 1. So quite a big variety, but there you are. So 12 hurricanes or 1 hurricane.